Hello all, welcome to part 2 of the SecurityTube GNU Debugger Expert course and certification. Now this specific lesson is titled What's Up with Symbol Files, and we basically start off from where we left off in the previous video. Now before I begin, uh, I had requested that you can either tweet the video or register for the SGDE, and I'm happy to announce that we have a number of people who've registered for the course. Thank you very much, and many others who've tweeted the video as well, which is fantastic. Thanks again. uh, what we had planned was that we would send the course material link through a direct message, and we've tried to send as many as possible, but unfortunately looks like Twitter throttles DMs, and I think if we send too many, probably we'll get banned. So what we've done is I've changed the tweet a video interface a little bit since the last video. You can click tweet the video and click on the tweet button. This will actually open up the whole tweet. You need to tweet this entirely, and if you're signed up already, probably just the tweet button would be there. If you haven't, you can sign into your Twitter account, and then just with a single click follow SecurityTube. We have some interesting updates which we go ahead and put out, so it'll be interesting to follow the SecurityTube account. I think if you're already following, it might just show probably the whole follow in a kind of grayed out manner, which is okay. And after that, you can go ahead and enter your Twitter ID and the email to which we can send the download link, right? Awesome. So this is how you can get the code file and the PDF slides for this video. And people who can probably go ahead and afford to support us a bit more, request you to register for the SGDE, and we'll send you a link to the high resolution videos, the slides and all of that, and in the end a mock exam and the certification exam. Okay, so in the previous video what we had just looked at is what are symbol files, the different kinds of symbol files. And now in this video, we want to dive a little bit more deeper and look at, well, what do these symbol files actually tell us, right? So what I've done is I have my Ubuntu machine up and running, and I have SSH'd into it just so that we have, a text terminal, which is where probably I love doing most of my work. I've coded up a very simple program, right? Basically adds numbers, subtract numbers, and just takes two inputs through argv, and basically converts both of them into numbers, and then uses the add number function which we have here on top to add both of them, and then the subtract numbers to subtract both of them. That's it. So let me go ahead and compile the file. The first time, let's just go ahead and compile without any debug symbols, right? So let me go ahead and say no debug. Okay, and let's also quickly, same time, go ahead and compile with debug symbols specifically for GDB. And there you go, we have both these files available. Now let's first load up the file with debug symbols, right? There we go. So with debug symbols, and as you've already seen from the previous video, it says red debug symbols. Now what all can you find with this, right? So let's try and open up a new terminal so that we can correlate both of these. Increase the font size. Okay, let's SSH back into the box. And let's go into SGDE video 2. There you go. And let's keep the source code open. Okay, and now let's go back here to the previous GDB session which is running. Now, one of the things which you can actually do if you just wanted to list the source file, if it is available, is just type in list. And what this does is that it starts listing typically from approximately the region where the main function is about to start. Now, if you want to list right from the top, you can just start with list and line number, which is 1, right? And there you go. You can hit enter and it kind of subsequently starts going down the file till the whole file is done. Now, a quick question you may have is the source code part of the symbol file which is actually being added as debug symbol in the binary? Well, the answer is no, right? The source code is kept separately. How do you prove that? So let's do a very simple experiment. All I'm going to do is I'm going to move out the C file and just rename it, right? Let's say C.renamed, right? So that now the source code does not exist, the same file name. And let's again start GDB with the debug symbol version. And now let me try and list the file. And if you notice, it just says no such file or directory. Awesome. So list is probably very, very useful when you have the source code. Probably you want to correlate a couple of things. If you don't have the source code, well, list is pretty much useless. Now, let's try and uncover a couple of things from the binary, right? So let's say you wanted to list out all the functions which are currently there in the binary with the help of the debug symbols. Let's say what we want to find is add numbers, subtract numbers, right? Then what you need to do is basically type in info and then functions, right? This is going to give you a bunch of stuff. As you can see, it says file, and basically it also tells you which file. And then you have all these 3 functions mentioned inside the file, right? Add numbers and subtract numbers is what you mentioned. Main is the mandatory one, which is also there, right? And these are part of the debugging symbols, right? You also have non-debugging symbols and a bunch of other stuff, which we'll look at in later videos. This part here is important. Now, just to do a quick compare and contrast, if I actually loaded up the no debug version and did an info functions, right? What you would notice is that you do not get all defined functions and there's nothing over here, okay? You, however, interestingly, still get add numbers and subtract numbers over here. So what that means is, well, you probably stripped the debugging symbols, but there are other symbols available as well. We'll get into all of this in later videos. Just wanted to point out that with debug, what advantages you have. Now, if you wanted to go ahead and look at all the sources, just type info sources, and this will actually tell you that this is the source code file which pertains to the binary, right? Now, let's probably type in info variables. And if you notice, again, we do not get any input here. The reason is info variables by default does not print any local variables. It'll just print global and static ones. Just to prove that, let me get out of this. Let's go back here and let's actually add some code. Oops. So let me go ahead and add a global variable. I think I still need to move the file back. To this. There you go. And let's open this file up. Let me just add a global variable here, right? Let's just call it int I am a global variable. Okay, done. Let me just quickly compile the files. So the first option is we're going to have no debug, and the second option is we are actually going to have the debug version, and we also give the -g GDB option. There you go. Let's open up the source file once again. Let's go back here. Let's load up the debug version, clear the screen, and let's type in info, and there's also kind of, tab completion, info variables. And if you notice, now you're able to see the global variable, int I am a global variable. Fantastic. So how do you look at local variables? Now, the way to do that is actually to mention the scope. So, example of scope is basically that if you're interested in looking at all the local variables in add numbers, you could basically go back here and say info, and then what you're going to do is specifically go ahead and mention the scope, and after that, if you hit a double tab, it tells you what are the available scopes to you. In our case, we are interested in add numbers, right? So you can just do add, hit a tab, complete, and if you notice, it gives us an interesting output. So you have symbol number 1 is a variable, length is 4, symbol number 2 again is a variable, and if you notice, length is 4, both of them are in 32-bit system, and then symbol sum again, length 4. Awesome, right? Similarly, you can actually go back here and say info scope, subtract numbers, and you get something similar. So this allows you to actually go ahead and look at what is available in the whole program, right? So we could also do main for what it's worth, and in main you first have argc and argv, then you have input 1, and then you have input 2. Now there's a bunch of other stuff about, this is a complex dwarf expression and blah blah blah, and a bunch of other things. Don't worry about them right now, right? For most of the purposes, as far as this course is concerned, we needn't worry about that. We've located the local variables. We'll see how we can manipulate all of this in later videos, right? Now, so we've seen info sources, we've seen info functions, we've seen info variables, where the key thing is it only applies to global and static, while if you want to look at local variables, you need to mention the scope, which is the specific function inside which you want local variables to be inspected and seen, right? Awesome. Now, the second question arises. Let's go back to our slides, right? The second question is, well, if you have a binary with debug symbols, is it possible to rip off just those debug symbols off the binary, right? And basically the program which allows you to do that, which is part of bin utils, is object copy or obj copy. All you have to do is give the option only keep debug, give the name of the binary file with the debug symbols, and then the file into which you want the debug symbols to be copied. So let's go ahead and try this out. Okay, so we have object copy and object copy, and we have only keep debug. And as I already mentioned, basically what one needs to do is give the binary file with the debug symbols, which in this case is debug, and then the output file, so let's just call it debug underscore symbols, right? If you do an ls in the current directory, you'll actually find the debug symbol files to be present, right? As you can probably imagine, this is going to be a cute little binary file. And just to prove to you that, well, debug symbols actually do exist in this file, let's actually search for a bunch of things we know should be here, right? So we should actually be able to find add numbers. And if you notice, you have add numbers in here. The other was, I think, subtract numbers. If you notice, here it is, subtract numbers. And similarly, very close to that, you notice the global variable which we defined. I am a global variable, the path to the source code file, and a bunch of other things, right? Awesome. Okay. So this is how you can actually strip the debug symbols of a binary with debug symbols. Oh, sorry. This is how you can, just a quick rephrase, this is how you can copy the symbol files from a binary into a separate file, right? What I wanted to mention is the debug symbols, of course, still do exist within the binary, right? They have not been stripped, they've just been taken out and copied into a separate file. Now, if you were interested in actually stripping the symbols of the binary, then you can use a utility called strip, and you can actually go ahead and say strip debug. Let's go ahead and say strip, and then after that you could mention strip debug, right? And then you could go ahead and mention the file or the binary from where you want to do all the stripping. There you go. Now this actually strips the debug symbols of the file. To prove it, let's actually load it in GDB, right? And if you notice, now it says no debugging symbols found, right? Now, in a previous demo, if you remember when we did info functions, even though it did not mention add numbers and all of that over here, it seemed to be mentioning those here, right? Now, if you want even these to be stripped out, which is like absolutely no symbol in there, what you need to do is, stuff, you can actually add an additional option, and that additional option basically says strip unneeded. What this does is this is going to strip all symbols, everything else, apart from what is a must have for the binary to actually load, work, execute, and function properly, right? So there you go, we've done that. Now let's again load that file in. Fair enough, it says no debugging symbols. But now let's actually go ahead and do info variables once again. And if you actually notice, it's practically nothing for you in there, right? Do info functions. And if you notice now, there is nothing in there, right? Your add numbers, subtract numbers, both of them are gone, right? Now, why is this all important from a security perspective? Now, a smart developer ideally should not ship a binary with debug symbols, right? Or with anything else added on for that matter. So a smart developer who's probably even a bit security conscious, ideally would run something like this on his binary before he goes ahead and gives it out to the rest of the world, right? Which is strip everything which is unnecessary, unimportant, and not required to run the binary, right? This is also good because it kind of brings down the size of the binary by quite a lot, and which is a good thing, right? Now let's go back. So we've gone ahead and stripped the symbol off, put it in a separate file. Now what if, let's say, you actually wanted to go ahead and use the debug symbols with a binary which actually does not ship with debug symbols by default. You have two options. The first one is you can load the symbol file inside GDB, right? So how do you do that? Let's go back. Let me run GDB and let's say the no debug version. Frankly, now both of them are equivalent to the no debug one. And if you notice, it says no debugging symbols found. Quite obvious. And if you do a quick info functions or anything like that, you would not see anything on top. Info variables, right? Again, nothing much. However, you can add the symbol file at runtime to GDB by just typing symbol-file and then basically giving it the debug symbols, right? Awesome, it says red. Now if you do an info variables, there you go. You have your debug information pack. So GDB has the capability to read the debug symbols separately from the binary, right? And a lot of times when probably you're working on a commercial application, you've installed it in your enterprise, crashes, there's some problem. Many a times, the product company may actually ship you the debug symbols to try things out, to probably give them a better trace and a bunch of other things, right? Awesome. The other option which you actually have is to add the debug symbol back to the binary, right? And this again is done with your friend object copy by giving it the option add GNU debug link, right? So how do you do that? Let's go back here and we say object copy and you have add GNU and then you have debug link equals the name of the debug file, which was debug_symbols, and then the stripped binary into which you want to add these debug symbols. So which in our case is EA underscore no debug, right? Now when you load this up in GDB, you would actually notice that it automatically says reading symbol files done, right? And then you can actually do info variables, see your global variable up there. You can do your info functions and you will really see your functions up there as well, right? Now, the key learning as far as this video is concerned, that not shipping with debug symbols does not mean there is absolutely no information about any symbol in it at all, right? In reality, there are a lot of other things which do get added, and as we've seen that we were actually able to uncover a couple of function names, even the variable, even though we did not compile with the -g option, right? So in such cases, the best option for you as a developer, as someone distributing a binary, is actually to use the strip unneeded option as well, right? Okay, so let's do a quick recap of what we learned in this video. So in the last video, we had said, hey, symbol files are these, absolute helper utilities which actually help the debugger in understanding the binary better. And you, as probably a reverse engineer, an exploit researcher, to also understand the binary better using tools like GDB. So what do these symbol files actually convey? Well, they tell us about, the different source code files from where these binaries came from, the variables, the functions, and a bunch of other things which we'll take up in other videos. What we learned was that info sources is basically going to list out the files from which the binary was actually compiled and linked. Info variables is basically just going to give you typically all the global and static vars, not the local variables. If you want the local variables, you need to use info scope and then the function name, right? Hitting info scope and then tab would actually go ahead and give you all the scopes available to you. Then you had info functions to list out all the functions. One little command which I've left is to actually dump the symbols into a separate file called, maint. Maint is basically maintenance, print symbols, and then the file name. Now, what if you wanted to rip your binary off all the symbol files, right? What we actually figured out was that there are two possibilities to do it. The first is you don't really change anything in the binary. You just copy the symbol files out. That's done with object copy with the only keep debug option. Now, if you really want to strip the debug symbols off your binary, use the strip command with the strip-debug option. Now, what we noticed that even after doing this, there are some remnant traces available which may allow a reverse engineer to probably understand your program better. So what you need to do is strip all unnecessary information out by using the strip unneeded option. This actually changes your binary, removes all the unneeded symbols, including the debug ones. This is exactly how any decently security conscious developer would probably ship his binary. Now, finally, we wanted to look at how to use symbol files if the binary does not ship with it. There were two options. One is to use again our little friend object copy to copy the symbol back to the binary with the add GNU debug link option, and the other was to read the symbol file inside GDB using the symbol-file option, right? Fantastic. Okay, question time. So if you do info files, you get this little weird output with a bunch of addresses and some section information here and there. So my question to you is, what is this, right? This is your assignment. Post the answers in the comments below. The next video, I'll show you the solution. So let's see who gets it first. What does info files give as output, right? Once again, if you want the PDF slides of this video and the code and binary files all nicely zipped into a zip file, you can either tweet this video or you can go ahead and register and support us with $50. Remember, $50 is just a one-time payment for the entire course, not on a per video basis. And this will help us produce such quality content more often, right? So that's all for this video. In the next one, we will look at inspecting symbol files using the nm utility. Thank you very much. Keep the tweets and comments coming. That is what keeps me going. Thank you. Have a great day ahead. Bye-bye.